This video is the second in a series of 4 videos that derive the kinematic equations. So this was a problem. Again, if you have not tried to work on this problem yet, stop this video, try to work on it first, and then you can check over it with this video. So we're continuing on from problem number 1, and the question is, how far did Dr. Perry travel during those 2 seconds? And the hint here is that it'll be useful to think about the general definition of average. So in this particular case, we are given that the initial velocity is 2 meters per second. We now know that the final velocity is 8 meters per second. We know that the time period over which that happened was 2 seconds. And we've also, from the previous problem, know that the acceleration is 3 meters per second squared. So as we're looking at this information, we're trying to find what is the displacement. We have to consider that we don't have a straightforward equation, one equation that will solve for the displacement for us. So we begin by looking at the fact that we have been talking about averages, and we know that the average velocity is equal to our displacement over time. So if we could somehow find the average velocity, we would be able to solve for the displacement because we know the time right now. Now, an average, when we're dealing with constant acceleration, and this is where the constant acceleration becomes important, the average velocity is just the initial velocity plus the final velocity divided by 2, kind of your definition of an average. So we can just take, in our particular case, that we know the initial velocity was 2 meters per second, and the final velocity was 8 meters per second, divide by 2, and we get that the average velocity was 2 meters per second. So his average velocity was a rate of 2 meters every second that passed. So if we did this for 2 seconds, we should find that our displacement is just 5 meters per second times 2 seconds, or 10 meters. We see that from this equation. If we plug this then into this equation, we get that d is the average velocity times the time, or 5 meters per second times 2 seconds, 10 meters, right? So now we're asked to try to solve for a general equation for what the displacement is given the average velocity. And we can see that from our 2 equations here. We knew that the average velocity is the initial plus the final over 2, and we know that the displacement is equal to the average velocity times the time. So we can just combine these two, and we get that the displacement is equal to v initial plus v final all over 2 times the time, which you'll often see me write as 1/2 vi plus v final times t. And that is our second kinematic equation. Let me just write this all out so it's very clear. The displacement is equal to 1/2 the initial plus the final velocity times the time. And that is the second.